Hi, in this video I'm looking at how to use the unit circle to calculate in exact values without a calculator the tangent, cosine and sine of multiples of 45 degrees, 60 degrees and 30 degrees. So if I'm interested in these angles and multiple of them, well, that means I can be doing things like 90 degrees is 2 times 45. 3 lots of 45 is 135 degrees. 60 degrees, we can multiply that by, 4, and 4 lots of 60 degrees will give us 240 degrees. Or, 30 degrees times by 5 is 150 degrees. We can, have any integer multiple of these, and we can work out the sine, cos, and tan of them. To do that, however, we need to have a bit of a look at our unit circle. So if I have a look at our unit circle, it's the thing that helps us. So we don't even really need the unit circle, but if we take everything back to the unit circle, it helps. So remember, my unit circle is a circle with radius 1, which means that it meets the x-axis at the coordinate 1, 0, the y-axis at the coordinate 0, 1, the negative x-axis at the coordinate negative 1, 0, and the negative vertical axis at the coordinate 0, negative 1. And we get this circle, which will hopefully look a lot better than what I seem to be able to draw. That's a decent enough circle. The shape of the circle is not really what's important, it's about how we use it. So let's have a look at, for starters, 135 degrees. So let's say, that I'm going to end up wanting to know what is the cosine of 135 degrees, the sine of 135 degrees, and the tangent of 135 degrees. So to work this out, I'm going to draw 135 degrees approximately onto my circle. So we said before, the 135 degrees is about 3 lots of 45. So we get 45, 90, 135 is going to be over here, sort of splitting it over here. So that angle there is our 135 degrees. Now, to calculate 135 degrees, we need to do a little bit of trickery. We only really know how to do sine, cos, and tan of 45, 60, and 30. So what we do is we take the rest of the angle, the reciprocal angle, the rest of the straight line angle that gets us back to the closest x-axis. So there's the negative x-axis here, so we get this angle back to this x-axis. And if we work that out, well, this would be a rotation of 180. So 180 minus 35 will give us 45 degrees. So I know that that angle in there is 45 degrees. And I know how to calculate the cosine of 45 degrees. Because I've got a right angle triangle that has side lengths of 1 and has 45 degrees inside it, and a hypotenuse of square root of 2. And I know that cosine of any angle is the adjacent side over the hypotenuse. So for 45 degrees, the adjacent side is 1 and the hypotenuse is the square root of 2. So I know that we have the 1 over the square root of 2, or if we rationalize the denominator, we have root 2 over 2. But that's the cosine of 45 degrees. I need the cosine of 135 degrees. And if we remember our definition of the unit circle and what cosine is, if I drop a line down here, remember the cosine gives us the x coordinate of that point. It's given to us by the cosine of the angle. So x is given to us by the cosine of the angle. So I want to know what's basically the sine of this. I've worked out its value. I know it's going to be root 2 over 2. I just need to know, is it positive or is it negative? And because we're in the negative realm, because this is 0, we have positive numbers this way and we have negative numbers this way, I'm going to have the negative of cos of 45 degrees for 135 degrees. Because 135 degrees is over here, and it has, if I drop a line down to the x-axis, that's a negative value. So I'm going to have the negative of the square root of 2 on 2 for my cosine of 135 degrees. If I do the same for sine, remember sine will give us the y value. So I want to know what's the y value of this coordinate, or the y coordinate of this point. How far above this, above the horizontal axis is it? How far vertically is it? So we have a look at sine of 45 degrees. And we can see, because sine is the opposite over the hypotenuse, we know that the sine of our triangle will be the opposite side is 1, hypotenuse is root 2. It's also going to be 1 over root 2, or root 2 on 2. So we know that the value of sine of 135 degrees is root 2 on 2, not 3. I just need to think, is it positive or is it negative? And because we're in the positive numbers for the y-axis, I'm above the x-axis, this is a positive 1 up here, my answer is going to be positive. So it's going to be positive root 2 on 2. So we'll just leave that. Tan is slightly more complicated. Now, tan, we can either do this two ways. Tan, I know, is defined as the y value over the x value. I also know that tan theta is the opposite over the adjacent when we come to our triangle. So if I think about tan of 45 degrees, I've got my opposite is 1 over my adjacent at 1. So I've got 1. But is it positive or is it negative? So I know my number here is going to be 1. So I now need to think about, is it going to be a positive 1 or a negative 1? Now, the definition of tan is that tan takes the angle we've got back through the origin and projects it onto this tangent to our unit circle down here. And the value of this, because it's below the vertical axis, is a negative number. So my answer is going to be a negative 1. The other way to think about it is from this definition of y over x. Our y, which was our sine, was positive, and our x, which was our cosine, was negative, and a positive divided negative is negative. So again, I've got a negative number there. So that's how we use our unit circle and our definitions from the unit circle of cosine, sine, and tan, or tangent, to work out exact values for any multiple of 45, 60, and 30. So let's have a look at another example. So let's move over to the side here. And let's have a look at, say, 210 degrees. So if I draw a quick picture of where 210 degrees is going to be, it's more than 180. So it's going to be down here somewhere. So that's our rotation around of 210 degrees. But to know what to play with, I need to work my angle back towards the nearest x-axis, which is that one there. And if I do, well, this line here is 180 degrees, a rotation of 180 degrees. 210 minus 180, that'll be 30 degrees rotation. So if I want to, say, work out the sine of 210 degrees, I'm really wanting to look at, to get my exact value, the sine of 30 degrees. So if I go to my other helpful right angle triangle, which is 30 degrees up there, 60 degrees down here, 1, 2, root 3, I can calculate the sine of 30 degrees, because sine is opposite over hypotenuse, which is going to be 1 over 2. I now know my value. I just need to think, is it going to be positive? Is it negative? So if I think about taking this point and taking it onto the y-axis, because that's what sine gives us, because it gives us the y. I'm below the vertical axis. I'm in the realm of negative numbers of y. So that means I've got negative 1/2. We can do the same for cos. So cos of 210 degrees, I can look at cos of 30 degrees, because that's my nearest angle back to the x-axis. And I can work out that the adjacent side is √3, and my hypotenuse is 2, because cos is adjacent over hypotenuse. So I know my value is √3/2. Is it positive or is it negative? Well, taking this back up to the x-axis, that's going to be a negative number. So because we're in the negative x values. So I've got negative √3/2. And having a look at tan of 210 degrees, well, tan of 30 degrees is, well, the opposite side is 1. The adjacent side is √3. So we have 1/√3. Or if it's rationalized, that's √3/3. So I know my value for tan is going to be √3/3. I just need to know, is it positive or is it negative? So if I go back to the definition that tan is y/x, my y value, my sine, was negative. My x value, my cos, was negative. And negative divided negative is going to be positive. Other way to think about it is take the angle back through the origin, put it onto that vertical line. That's going to be a positive because it's above the vertical axis, because it's vertical on the y-axis. So I know this is going to be a positive √3/3. So that's another one. Let's do a couple more. So my next one, let's going to have a look at 300 degrees. So drawing a quick picture of 300 degrees, we would rotate 90, 180, 270. We'll have about 300 degrees. So now if I look about taking this angle back to the closest x-axis, which in this case is this one, I won't want to come back here because that's too far away. This is closer. And I think about, well, a full rotation would be 360 degrees. So 360 minus 300, well, that would mean that this is a rotation of 60 degrees. So when I go to work out sine of 300 degrees, I really want to temporarily look at sine 60 degrees. And having a look at our 30, 60, 1, 2, √3 triangle, sine is opposite over hypotenuse. So we're going to have √3 opposite over hypotenuse of 2. So I know this has a value of √3/2. I just need to know, is it positive or negative? Sine is again the y, so if I bring this back to the y-axis, that's going to be a negative number because it's below the x-axis. So we have negative. Looking at the cos of 300 degrees, well, cos of 60 degrees, our adjacent side is 1, our hypotenuse is 2, so I'm going to have a half. So cos of 300 is also going to be a half, but is it going to be positive or negative? Taking this up to the x-axis, that's now in the positive realm of the x-axis because we have positive numbers here, so it's going to be positive a half. Having a look at the tan of 300 degrees, well, tan, if I make sure that appears on the screen, tan of 60 degrees, well, tan is opposite over adjacent, so it's √3/1, which is just √3. So a tan is going to be √3. Is it positive or negative? Well, thinking about where is it hitting the tangent to my unit circle, it's hitting down here in the negative numbers, so it's negative. Or if we think about the y/x, our y was negative, and our x, which is here, is positive. And negative divided positive is going to be negative. So we have a negative. So there's two ways of figuring out tan. I'm going to do one more because there's something we haven't really looked at. What if, say, I want to know the sine, cos, or tan of 270 degrees? So this time, if I go to 270 degrees, that's going to be down here. That's, if I get a more obvious color, that's going to be down here, straight, up, and down. So now, I've got to actually treat this one slightly differently. I've actually got to go back to my original definition of my unit circle, where I've got to think about what's the coordinate of this point. Okay, so if I put on a quick unit circle, where around that, if I can draw a slightly straighter one, well, slightly better curved one, really, I don't want a straight circle. And I think about, this is the coordinate 1, 0, this is the coordinate 0, 1, this is the coordinate negative 1, 0, and this is the coordinate 0, negative 1. So when I go to work out the cos of 270 degrees, I really want to know what is the x coordinate, because that's the definition. X is the cos of the angle. Now the x coordinate of this point down here, or this point down here, if I want to think about rotating down here, x is 0, because this is xy. So my value of cos is 0. If I think about sine of 270 degrees, I want the y coordinate, because our sine is defined by, our y is defined by sine, or sine is the y coordinate of the point. The y coordinate of this point is negative 1, and that's our answer. Tan of 270 degrees, not so obvious. So remember, it takes it back through the origin and tries to hit this vertical line. So if I try to take it back through the origin, I'm still parallel to the line though, because I'm on the axis, which is parallel to this line. So I can't reach it. I don't get it. It's undefined. I can't make it. I don't never meet that line. If we also go back to the fact that tan theta is y over x, well, y was negative 1 and x was 0. And now I'm dividing by 0, and we can't do that. So this is undefined. It doesn't exist. There's no answer there. We can do similar, say, for if I wanted to do just quickly 180 degrees. 180 degrees is over here. Let's put that in a more obvious color. 180 degrees is over here. So cos of 180 degrees, well, that's the x coordinate, which is negative 1. Sine of 180 degrees, that's the y coordinate, 0. And tan of 180 degrees, well, now I can go back through the origin and reach this point at 0. Or if I think about using this y over x definition, I've got sine, my y was 0, x, my cos, was negative 1, and I can do 0 divided by negative 1, because 0 divided by anything is 0. So tan's value on this point is 0. So there we go. If you know about your unit circle and you can play around with it, we can work out any integer multiple of 45, 60, and 30. So whether it's 90 degrees, 180 degrees, 270, 360, or 135, 240, 150, 300, 210, any multiple of those can be worked out by thinking about the unit circle. Where is the angle? What's the shortest reciprocal angle back to the x-axis? Shortest angle back to that x-axis, well, that one doesn't count for that. And then work out the cos, sine, or tan of that angle, and then think, is my answer positive or is it negative, depending on which realm of the axis I'm hitting for my x and y coordinate. If I ended up on the axis, I've just got to think about what is the coordinates of those points on the unit circle. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And if we happen to be 90 degrees or 270, we're on the y-axis, tan is undefined because we never meet this vertical line, or we end up dividing by 0.